In this lecture, we're going to learn about the for each algorithm in the C++ standard library. This is an algorithm you can use to apply a given function to any element in the container. Here we have a bunch of containers we're going to apply this on. We have an std vector, we have a row array, and we have an std set. You can really use anything here. And we're going to set up a callback, which is a function-like entity. In this case, it is a lambda function. And we're going to apply this lambda function on any element in our collection here. We can do this using the for each algorithm, and we're going to be looping through the algorithm, applying this callback on each element in our function. In this case, we want to print the element, and we're going to see that we can print this out. Hopefully you can see how this is going to make your code much easier to work with. You notice you can really try your best to even eliminate loops that loop through elements doing things, and do that through the for each algorithm, and encapsulate what you want to do in the callbacks that you pass to this algorithm here. This is going to work really well. So for example, we can also loop again using the for each algorithm. And in this case, we want to modify each element in our collection. And what we do is increment each element. You see that our callback here is going to pass the parameter by reference. So each element in the collection is going to be passed into this function. We're going to be incrementing that element in place because, again, this is a reference. And if we print our collection again, we're going to see that each element has been incremented by 1. This is something you can do in your C++ programs. Let's look at another example. We're going to set up a simple functor, which is going to be sum here. And we will be using this to increment and store the result of our sum in this member variable here. Let's go down and look at our collections on which we can use our for each algorithm. Here is our call for the for each algorithm. We're going to pass in the beginning iterator and the end iterator, and then we're going to pass our callback, which is going to be this functor here. The special thing about this is that each time this functor is called, it is going to add to the member variable here, and the result will be stored in the same functor here that we have as a local variable in our main function. So by the time the for each algorithm is done, our sum is going to still be stored in this object, and we can print that out as you see right here. It is also possible to capture the result of our for each algorithm as a return value to this. And again, I know that I could do this from reading the documentation. You should really read your documentation to understand the behaviors for these algorithms. If we go down here, we're going to see that we have another way we can do the same thing. We're going to set up a variable which is going to store our result. And then we're going to do the same for each thing. We're going to pass in the beginning iterator. We're going to pass in the end iterator. Then we're going to pass a callback, which is going to capture our local variable in which we're going to be storing the result. And we're going to capture this by reference because we need to modify it. Then in our body, we're going to add to our result here. And by the time the for each algorithm is done, we're going to have the same result stored in our result variable, and we can print this out here. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is the for each algorithm we want to play with here. Let's grab our template files and put them in place. And we are going to open this up in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. Let's clean this up and close the left sidebar. We're going to include the algorithms header, and we need std set. I think we need this, and we need vector. Let's put the code in our main function here. We're going to set up our collection types. We have an std vector, a row array, and an std set. Any of these will do really. We're going to set up a simple lambda function which is going to print an element that we pass in our parameter list here. And then we're going to pass our print lambda function as a callback to the for each algorithm. You see the call right here. So we pass the beginning iterator, the ending iterator, and we pass our callback. And this is going to loop through our collection, printing out each element here. This is going to work really well. Let's pass this through the compiler to see it run. The build is good. We can bring in a new terminal window clear and run Rooster, we're going to see the elements printed out. We have our std set, so this is going to order our elements. That's why we see these guys printed in order here, because an std set is going to store things in order the moment you put in the data. This is something we already know. But it is possible to change and store our data in a row array. Let's pass this through the compiler and see how this works. The build is good, so let's clear and run Rooster. We're going to see the data printed out exactly in the same order as we put it in our collection here. We can use std vector. Let's make sure you see this. We can pass this through the compiler. The build is good, so let's clear and run Rooster, and we will see our data printed out here. So this is one way you can use the for each algorithm. This is going to hide the looping we do underneath to get this thing to work. My guess is that the for each algorithm is going to do the looping anyway, but these loops are not going to be exposed to the level of your C++ program. And this is an algorithm you're going to be looking for if you need to do a kind of operation for any element in your collection. This is going to make things easy if you combine this algorithm with a bunch of function-like entities you can set up in your C++ program. Another thing we can do is modify our data in our container using the for each algorithm. For that, we will call our for each algorithm, passing the data we are familiar with now, the beginning iterator, the end iterator, and we need to pass in a predicate which is going to be used to do things on our collection here. In this case, we're going to pass in a lambda function which is going to pass the parameter by reference, because we want to modify the original thing that was passed into this parameter here. And in our body, we're going to increment to change the data in place. And if we print the data again, we're going to see that the data in our underlying container has changed. Let's pass this through the compiler. We are going to use GCC. The build is good, so let's clear and run Rooster. We're going to see that after we modify our collection and print it again, any element will have incremented by 1. You see we had a 3, now this is a 4. We had a 4, now this is a 5. We had 267, now this is 268. We were able to increment our data using the for each algorithm, and this is something you can do in your C++ programs. Let's do another example. This time we're going to go on top and set up a functor, which is going to have a function called operator that adds to our member variable the parameter that was passed. And what we can do with this is store the sum of elements in our collection in this functor here using a for each algorithm. So let's go down here and do that. We're going to put in our code. We're going to create an object of our functor, and then we're going to pass this as a callback to our for each algorithm, not forgetting the beginning and ending iterator that this algorithm needs to work. This algorithm is going to do its job and store the sum in our functor here. And by the time line 44 runs, the sum is going to be stored in this functor here, and we can print this out, and we're going to see that the sum is going to be n. Now, some people must be asking, why are you capturing the result in the functor here? Well, if we go to the documentation for it, we're going to find answers. Let's go there and find our for each algorithm. Let's open this up. If we look at this piece of documentation here, you see that our functor is passed as this third thing, which is called unary function here. This is really code for function-like entity. You can pass in a function pointer, you can pass in a lambda function, you can pass in a functor, you can really pass in any kind of function-like entity we had a chance to learn about. Now, this thing that is passed as a parameter is going to be the same thing we return. You see the return value is also f. So this suggests that we can capture the result of our for each algorithm and store that in our functor here. And we need to do this because this thing is being passed by value. So the changes we do to this parameter here are not going to be reflected in the original thing. That's why we need to assign the result of our for each algorithm back to this functor object here. Let's pass this through the compiler and show you that this is going to do the sum and store things in our functor here. We can clear and bring up a terminal window. And we're going to run Rooster, and we're going to see that our result is going to be 304, which is going to be the sum of these elements here. Now, let's try and take out our assignment here and show you that if we don't reassign the result of the for each algorithm to this functor, this sum functor is really going to be empty, so it's going to contain the 0 that we had in by default here. Let's pass this through the compiler and show you this. The build is good, so let's clear and run Rooster, and we're going to see that our result is 0. This is something you need to be aware of. Let's turn this back to do our assignment, and I am going to show you one other way to do the same thing. We can achieve the same thing by setting up a variable which is going to store our sum, and this variable is going to be a local variable to our main function, so nothing special here, but we are going to capture this variable in our callback function, which is a lambda function, and then we're going to be modifying this in place at each iteration, and we're going to be adding a copy of the element we have at each iteration here, and this is going to give us the sum that we want. So if we print this out, we're going to see that it is the same thing as we had on top here. Let's pass this through the compiler. We're going to use GCC, so the build is good. We can clear and run Rooster, and we're going to see that we have the same results. This is working. This is all I had to share in this lecture, showing you how you can use the for each algorithm. If you want more information, you can come to the documentation here, and you're going to have more than you probably need. But this is the best place to find information about these algorithms. And if you go down, you're going to find a bunch of examples. You're going to see that this is very similar to what we just did in this lecture. And this was a huge inspiration to what we just did. We are going to stop here in this lecture. In the next one, we're going to learn about the max element and min element algorithms. And if we go in our list, I think we're going to find them. Let's scroll down a little bit. I think we can even do a search. So let's do Control F and search for max element, and we're going to find that right here. We're going to learn about these algorithms in the next lecture. Go ahead and finish up here and meet me there.